looking at notes U-1, elevation and depression. This is very, very similar to notes O-1. So maybe turn back, flip back and look at O-1 and reflect on what you learned in O-1. So notice the angle of elevation or depression is from the horizon, or in other words, the horizontal piece of the triangle. So angle of elevation would be this angle here from the horizon looking up. Angle of depression would be from the horizon looking down. Okay, so elevation, depression. So this is the exact same thing of something we've already done. It's just you're going to see these words elevation and depression. So number 1, a surveyor is standing 115 feet from the base of a building. So here's a surveyor. He is standing 115 feet from the base of a building. So here's your building, right? Building. Okay. The surveyor measures the angle of elevation to the top of the building. So angle of elevation, right, looking up to the top of the building is 78.3 degrees. How tall is the building? So in other words, what's the height? What's the y? So which trig function are you going to use? You want y, you have x. So the trig function that uses y and x would be tangent. So tangent of 78.3 degrees equals y over x. We don't know y, over x, which is 115 feet. So just like we've done before, make a fraction on the left, we have a fraction on the right, so cross multiply. So tangent of 78.3 degrees times 115, so 115 times tangent 78.3 degrees equals 1 times y, which is just y. So now to solve for y, you plug this in the calculator. Of course, I just cleared my calculator, so then you want to go to the mode. Make sure you're in degree mode, which I'm not, so glad we checked. Second, quit out of that and type this sucker in. 115 times tangent 78.3 degrees equals, my answer is, the height of the building is 555.314 feet. That tells me my y, which represents the height of the building. All right, look at number 2. The sonar of a Navy cruiser detects a submarine that is 200 feet below the surface of the water. So here's your cruiser, your ship, your boat, whatever you want to call it. Okay, the sonar of the Navy cruiser detects a submarine that is 200 feet below the surface of the water. So that means the vertical distance from the water to the submarine is 2,000 feet. So this is the water, obviously, it's the cruiser's on the top of the water, the submarine's below. Okay, that vertical distance is 2,000 feet. The angle of depression between the water line, so that's our water line, and the submarine is 34 degrees. Okay, how far is the submarine from the cruiser? What's this distance from the cruiser to the submarine? So what do we have here? We have y, our unknown as r. What trig function uses the ratio of y and r? That's going to be sine. So sine of 34 degrees equals 2,000 y over r, which our r is the unknown. Okay, make our fraction, cross multiply. So r times sine of 34 degrees equals 1 times 2,000, which is just 2,000. Okay. And so get r by itself, so divide by sine of 34 degrees, divide by sine of 34 degrees. Okay, you get r equals 2,000 divided by sine of 34 degrees. So the distance from the cruiser to the submarine is 3,576.583 feet. All right, so next, moving along. Number 3, the angle of depression of a buoy from the top of the something bay lighthouse, 130 feet above the surface of the water, is 6 degrees. So hopefully you know what a buoy is, out in the middle of the water. Okay, here's our lighthouse. Okay, it says the angle, that's the water, that's the buoy in the water. The angle of depression of a buoy from the top of the lighthouse, so this angle of depression here is but lighthouse 130 feet above the surface of the water. So it told us that the lighthouse is 130 feet above the water. So if this is 130 feet, since we've made a rectangle here, this is 130 feet. Okay, the angle of depression is, that's what I was looking for before, is 6 degrees. This is 130 feet. We want the distance from the base of the lighthouse to the buoy. So the distance from the base of the lighthouse to the buoy. Well, the distance from here to here, since again we created this rectangle, is the same as the distance from here to here. So that's like your x, your horizontal. That's what you want to know. So which trig function uses x and y? So that's going to be tangent again. So tangent of 6 degrees equals y over x. So put this over 1. So then you have x times tangent of 6 degrees equals 130. When you multiply 1 times 130, divide by tangent of 6 degrees. Okay. So x equals 130 divided by tangent of 6 degrees. So the distance from the base of the lighthouse to the buoy is 1,236.867 feet. We're still talking feet. All right, number 4. So at a spot 100 feet from a house, the angle of elevation to the bottom of the chimney is 27 degrees. So I imagine this is the house. Okay, this is the chimney sticking out. Okay, so here's our house. Y'all know that a chimney sticks out. So this is the chimney. Okay, so here at a spot 100 feet from the house. So here's the spot 100 feet from the house. The angle of elevation to the bottom of the chimney, so this angle, is 27 degrees. Whereas the angle of elevation to the top of the chimney is 29 degrees. Find the height of the chimney. So all I want is the C, the chimney height. We'll call this the Y, the house height. So we don't know either. We don't know the house height and we don't know the chimney height. Okay, so 2 unknowns. We'll have to make 2 equations and solve a system of equations. So just like we've done before, we have a little triangle and a big triangle. So for the little triangle, okay, we're going to use tangent because we have an x and a y. So tangent of 27 degrees equals y over x, which is 100. Okay, for the big triangle, we have tangent of 29 degrees equals, for the big triangle, that would be the whole height. So C plus Y. Okay, for the whole height of this big old triangle would be C plus Y over 100. Okay, so here we can use the substitution method, solve for this variable here. So get y by itself. So again, cross multiply, so 100 tangent 27 degrees equals y, right? This times this on this side equals this times this. So now that I've got y completely by itself, I can substitute that in for y into this equation. So here I am also going to cross multiply and substitute in for y. So I would have tangent 100 times tangent of 29 degrees equals 1 times this, which would just be c plus y. 1 times c plus y would be c plus y. But we know what y is. Y is c plus 100 tangent of 27 degrees. Okay, so that's 2 steps there. Hopefully you followed along. So not only did I cross multiply, but I also substituted in for y. So now I want c completely by itself. So move this over to the other side. You would have 100 tangent 29 degrees. This plus would become a minus 100 tangent 27 degrees equals c. That makes sense, y'all? That should make logical sense to you. We are taking the distance of this whole thing and subtracting the distance of just the little piece to give us this little sliver distance. Okay, so in your calculator, 100 tangent 29, make sure you close it, 29 degrees, minus 100 tangent 27 degrees equals, so the chimney is 4.478 feet tall. That's the chimney. That makes sense. That point didn't really show up. 478 feet tall. Okay, last problem here, number 5. You are holding onto a 30-foot string tied to a kite stuck in a tree. This is you're holding onto a kite. This is your string, 30 feet, stuck in a tree. So the kite's up here stuck. The kite is 23 feet off the ground. So again, drop that down and make this rectangle here. That's telling you that the kite is 23 feet off the ground. So if this is 23 feet, this is also 23 feet because the rectangle created. What is the angle of depression from the kite to you? So what's this angle? Don't know. But what we do know is we have the y and we have the r. What trig function uses y and r? That would be sine. So sine of theta, which is our unknown, equals y over r. How do you get rid of the sine to find the theta? Well, you're going to use sine inverse. So sine inverse sine theta, what you do to one side, if we're finding the sine inverse on this side, we must do sine inverse on this side of 23 over 30. How cool is this? So here those undo each other, and you're left with theta equals sine inverse of 23 over 30. So a big thing, okay, use the inverse or the arc when finding an angle. Okay, so in your calculator, sine inverse of 23 divided by 30, and of course that spits out, what mode are we in? We're in degree, so that spits out a degree. So make sure the angle of depression is 50.055 degrees. If you don't put that degree sign, it implies radians, and that would be a totally different angle measure. So make sure you don't forget that. That's it for today.